Hello everyone. Welcome to this channel where we are presenting lessons in mathematics. So in this presentation, we want to see what groups and subgroups are. But before that, we are going to look at other concepts that would help us to define groups and subgroups. All right, I must be quick to mention that this video is useful to those that are doing their undergraduates, their first degrees, Bachelor of Science, maybe Bachelor of Arts, as well as those pursuing Masters of Science in mathematics. All right, and this course, these concepts can come under the course advanced abstract algebra. Others would call it modern algebra. All right. Now to do that, we'll start by defining binary composition. We want to see what a binary composition is. All right. Now, we are going to say, to define a binary composition, we need a non-empty set. All right. We need a non-empty set. So we are going to say, let S be any non-empty set. Empty set. All right. Then what can we say? Then a function can call it star, such that the Cartesian product of S will give S for every A and B in S, all right, and star of A, B is also in S, all right, is called a binary composition. Binary composition. So that is basically the definition. All right. That is basically the definition. Okay. Now you need to note that. Sometimes we denote star AB by just A star B. This star can be any function. Sometimes you can say FAB like that. All right. So that is a binary composition. That is a binary composition. Now, what does it mean? Maybe this definition may not really carry weight. What does it mean? This simply means that an operation, e.g., addition, subtraction, multiplication, division, or we can say this etc. Is a binary composition. If after applying if after applying the operation, the answer belongs to the same set. The same set. For example, there is a set that you are considering. You take, for example, your operation, let's say addition. So after doing some addition, whatever answer that you're going to get, if it is still in that set, if the sum is still in that set, then you can say addition in that case represents a binary composition. Represents a binary composition. All right? Also, that means that the binary composition associates every pair of elements in set S. I've used S was the one that we have taken, all right, to a unique element in set S. That's what it means. So it is a binary operation if at all, or composition if at all. When you apply some operation, all right, the answer that you are going to get is still within a set. That is called a binary composition. Okay. Now, to make our understanding, to understand this concept, maybe look at some examples, counter examples. Okay. Maybe this is our first question. Let's consider the set of integers as our set, as our non-empty set. Okay. Dear, what's wrong? Why? Eat now. Okay. Okay. That we can say our set is a set of integers. All right. The set that we are considering is a set of integers. Now, we can say, is addition, it's a question, addition a binary, we want to check this, a binary composition under the set of integers. This is what we would want to check. All right. Now, we have that S is a set of integers, all right? And that our operation, our star here is, we want to take a plus. Okay, is it possible that when we add two numbers, the sum will still be an integer? If it is yes, then we'll say addition is a composition under integers. All right. Now, let's take A and B as the elements of Z, or a set of integers, in short. All right. Then we know that A plus B will always be an integer. So upon applying this operation, upon adding, the answer will be an integer. What do we mean? If I take 2 and 3, all right? So 2 plus 3 is equal to 5, which is what? An integer. Implying therefore that addition is a binary composition under a set of integers. All right. So therefore, addition is a binary composition under the set of integers. Okay. Under the set of integers. Or we can say, or we can simply say, the set of integers, all right, is closed. Under the composition addition. All right, because when we apply this operation, the addition, on some numbers, on some integers, the answer will still be an integer. Therefore, addition is a binary composition. I hope it is clear. We can look at we can take another example. We say question 2. We take S to be Z, to be set of integers again. And in this case, we take our operation to be multiplication, or maybe we can start with the subtraction. All right. Now, if we take A and B as elements in Z, all right, we know that A minus B will always be an integer, right? Always be an integer. E.g., 2 and 3 belong to set of integers, implying therefore that 2 minus 3 is equal to -1, which is a set of what? Integers. Hence, subtraction is a binary combination. Is a binary composition under a set of integers. All right. We look at another example. Maybe we take our S to remain as Z set of integers, and our operation that we are going to consider is multiplication. Okay? Now, here please take note, it's supposed to be for every A and B in Z. It's very important. Every. So for every A and B that are integers, all right, we know that A times B will always be an integer. Hence, multiplication is a binary composition under the set of integers. Okay? Number 4, we take our S to be the set of integers, and our operation in this case, we take a division, or we can use this. All right? Clearly, we for every just a minute, for every A and B in Z, A slash B is not an integer. All right? Is not an integer. E.g., we take 2 and 3, or we take 1 and 2, as integers. Okay? Then 1 divided by 2 is equal to 0.5. This is not an integer, right? So when we get two integers, apply division, the answer we are going to get is not an integer. Hence, division is not a binary composition. Under the set of integers. I hope we are okay with the definition of a binary composition. I hope you're okay with the definition of a binary composition. If you have enjoyed our presentation, subscribe and share. Look forward for the next videos that will talk about properties of binary composition before going to the definition of groups and subgroups. This has been Piri Kamban. Right? You can reach out to us on this, or (0979673809). Thank you, and don't forget to subscribe. Thanks so much. Till next time, shalom, shalom.